Hello there. I am Saif Shiraj and I am a graduate student of mechanical engineering. I already graduated in May 2013 and I worked under Professor Asmatulu and Dr. Anil Mahapatra. Here today I am going to present a tutorial session on GAMRY works regarding Nyquist curve and Tafel curves, the most important two curves about the corrosion studies by GAMRY Framework. So right now I am showing how to set the GAMRY cell. This is the corrosion cell, and the circuit here, it is not an DC circuit, rather it is an AC circuit. So here are the cords we see here from the GAMRY potentiostats plugged into the GAMRY potentiostat, and here are the ends of these cords. We see the orange ends, green, blue, red and white. Among all these 5 ends, only 4 will be, among the 6 ends, only 5 will be used here, and this is called the working end, and this is called the reference end. We can see here on this mouse pad, you'll see green is working sense, white is the reference, red is the counter, and orange is the counter sense. And here also you see the same. So when we are gonna set the cell, suppose it's a piece of metal that we are going to study on. We are trying to know the corrosion properties. I think the Tafel equation parameters of this specific material. We are trying to know it. On that case, what we have to do is we have to unscrew this end, and here when it will be taken out, the thing is like this, and that's how it works. So suppose I'm gonna take it this way, okay, and this metal going in between the cell's hole and this working end, okay, this way. So I can just say that in one hand it's gonna be kind of tough, but I'm trying. Suppose this way, it works this way. Okay, here we can, here I think it is gonna work. Okay, so what we are gonna do here is, see, this way, and we have to Okay. So we see the metal has been set here, and you can screw it a little bit more. So it is the metal piece is set. Now in this cell you have to pour in the corrosion liquid you have to work with. I mean, it depends on your application, on which application this metal piece is gonna be used, because corrosion parameters will change. I mean, the taffel parameters and the pattern of the Nyquist curve will change as per the corrosion liquid. In our cases, we used the metal magnesium, actually magnesium alloy AZ31, and the corrosion fluid we used, it was a phosphate buffer solution. We used phosphate buffer solution because it is actually nothing but simulated body fluid, and we wanted to see how magnesium works against body fluid, because our application is to use magnesium as an implant material. So it is gonna be inside human body and it is gonna react with our body fluid. That's what we try to do in the GAMRY work, and so we used some simulated body fluid and we used PBS solution for that purpose. So you have to know well what corrosion liquid you actually need. So after pouring in the corrosion liquid and setting the material here on the working end, the green will go to green, the blue will go to blue, here the orange will go to orange, the red will go to red, and here it is for the reference electrode. For reference electrode, look at this. We took it here. This reference electrode will go inside, so that this tip, here it is. The tip gets in touch of the corrosion liquid. Okay, so it will be set this way, and here the other end of the cord of the reference electrode, it will be plugged into the white port, just like this. I'm working with one hand and my other hand is holding the camera, so I hope you'll take it easy. That's how it is set. This is how the cell look like, the corrosion fluid. So after setting it, what you have to do is you have to turn on the GAMRY potentiostat. Here is the button. Turn it on, and now you see the button is, the light is blue, and now it's turned into green. See, now the device is ready. I mean, USB means the computer CPU, it's getting data from the GAMRY, and the GAMRY device also got the power, so it is ready for the work. So right now, after setting this thing, all this thing, we will go to GAMRY Framework. Okay, the GAMRY Framework pops up. So to run an experiment, we have to go to the experiment. Click here. You will find some options. Drops down, and to run the tafel curve one, you have to choose DC 105. See, and from DC 105 again go down, you have to choose potentiodynamic. This one. Okay, now here pops up the window. It needs some values. So here the initial voltage and final voltage you can choose as you like, and these values will not be exactly followed by the GAMRY, but what will be exactly followed, it is the volt difference between the initial and final. Suppose your original curve can start at 1.5 volt and can finish at negative 2.5 volt. Not necessarily it is gonna start in 2 volt and finish at negative 2 volt, but it will maintain the same volt difference. Here you have put 2 volt and the final is negative 2 volt, so it's a total of 4 volt difference. The curve will maintain the same volt difference between its initial and final value, I mean the voltage value. And about the scan rate, if it is smaller, the curve will proceed slowly. I mean every single the difference between 2 points on the graph will be the scan rate actually. So if you put it higher, the curve will be done quickly. If you put it smaller, the curve will take more time to finish. Sample period is 1 second is good, and sample area, it is the area of the whole of the GAMRY cell actually. I think the whole you guys will be able to see. Here you see the hole. Here this hole, through this hole the metal gets in touch of the corrosion liquid so that corrosion can happen. So this is the sample area. For this cell it is not 4.85. This cell is the this cell's sample area will be something different than 4.85. You have to measure it again. And density, it is the density of the metal or the other material you are going to use. Equivalent weight, it's a metal constants, and these things are okay. After all this thing, output file name and some notes, fixing everything, you are gonna click OK, and the curve will run. This time it is not gonna run because we don't have any corrosion liquid actually, so we are not gonna have any curve. This is how the potentiodynamic curve have to be done, and then this is how you have to work on.